When determining the change in enthalpy for an entire reaction or physical process, the delta S, that's what I've written here with a little delta sign in front of it, what we do is we write down the individual S values for each substance in my reaction and then insert them into this equation. So I've got the sum of all of the S values of the products. That's what this epsilon sign means. It means the sum of. I take that number, put it here, and then I subtract from it the sum of the analogous term for all the reactants over here. One thing that's important when we do this kind of problem is we need to make sure when we look at our table that we don't accidentally pick the wrong substance. For example, carbon in solid form actually has multiple different forms of solid carbon. You can have solid charcoal, graphite, or diamond. When we look at our entropy table, we need to make sure to write down the value here that I've written, 2.43, which corresponds to carbon solid in its diamond form, not any of the other forms. Make sense? By analogy, we look at our table and find O2 gas as an entropy value of 205 and CO gas of 197.9. Now don't confuse this with enthalpy or H values. Delta H are formation values for substances in their elemental state and physical state. Solid, liquid, or gas such as O2 gas are 0. That's not the same as entropy values. Entropy values are S's, not delta H sub F's. Okay? With all of that said, let's take these values and insert them down in this equation. I've got coefficients here, a 2, an implied, not written, but implied or understood 1 here, and a 2 here. So I need to make sure to take that into account. So I've got 197.9 here for my product, and I have to multiply it by the 2 coefficient tied to the CO. So that is the sum of all of the entropy values of my products, because there's only one product. Then I'm going to subtract from that the analogous terms for my reactants. I've got 205 for my O2, and there's only an implied 1 coefficient there, so I don't have to multiply the 205 by anything. And then I need to add to that my 2.43 multiplied by 2. You see that all okay? So again, I've got the sum of my products, the sum of my reactants, and I subtract the reactants from the products. When you do this in your calculator, you need to make sure that you do it very carefully. Use multiple lines if necessary, use parentheses wherever needed in order to make sure that you don't accidentally put something where it doesn't belong. When I ended up doing that on my calculator, I got positive 185.9, which lines up with answer B.